The hidden consequences of groundwater depletion and industrial agriculture. The extraction of vast amounts of groundwater and the evolution of industrial agriculture are issues of growing concern due to their profound impacts on the environment, geological stability, and food quality. These practices have far-reaching consequences that affect our atmosphere, ecosystems, and the very soil that supports plant life. Atmospheric changes and climate impacts. One of the most immediate effects of groundwater extraction is the increase in atmospheric water vapor. Water vapor is a potent greenhouse gas, and its presence in the atmosphere can influence weather patterns and climate dynamics. The volume expansion of water when it transitions from liquid to vapor is significant. 1 cubic meter of water converts to approximately 1,247 cubic meters of gas. This substantial increase in volume contributes to the buoyancy of air parcels, making them rise and potentially leading to cloud formation and weather phenomena like thunderstorms. The presence of more water vapor in the atmosphere can enhance the greenhouse effect, creating a feedback loop that accelerates global warming. This increase in atmospheric water vapor can also affect local weather patterns, potentially leading to more extreme weather events. Moreover, vertical transport of water vapor can reach the upper troposphere and influence global circulation patterns, contributing to long-term climate change. Geological and environmental consequences. The depletion of groundwater has equally concerning geological and environmental impacts. The formation of underground cavities due to the removal of water can lead to several adverse effects. 1. Land subsidence. This is the gradual sinking or sudden collapse of the ground surface, often resulting in significant damage to infrastructure such as buildings, roads, bridges, and pipelines. Subsidence is a common consequence of extensive groundwater extraction. 2. Sinkholes. These sudden depressions in the ground occur when underground cavities collapse. Sinkholes can be dangerous and destructive, leading to property damage and potential loss of life, particularly in areas with soluble rock formations like limestone. 3. Earthquakes. While tectonic forces primarily cause earthquakes, significant changes in subsurface pressure due to groundwater extraction can trigger seismic activity. The reduction in pressure can cause faults to slip, leading to induced seismicity, especially in areas with existing fault lines. 4. Landslides. The removal of groundwater can destabilize slopes, increasing the risk of landslides. This is particularly relevant in hilly or mountainous regions where groundwater depletion can compromise slope stability. 5. Soil compaction. Groundwater removal leads to soil compaction as soil particles are pressed closer together, reducing pore space and soil permeability. This can affect agricultural productivity and natural vegetation. 6. Reduction in aquifer storage capacity. As the ground compacts and subsides, the storage capacity of aquifers can be permanently reduced, exacerbating water scarcity issues. Even if recharge occurs, the aquifer may not hold as much water as before. 7. Impact on surface water bodies. Groundwater and surface water are interconnected. Depleting groundwater can reduce the flow to rivers, lakes, and wetlands, affecting ecosystems and water quality. 8. Impact on ecosystems. Ecosystems that rely on stable groundwater levels, such as wetlands and riparian zones, can be adversely affected. Changes in groundwater levels can alter habitats and water availability for plants and animals, potentially leading to biodiversity loss. The degradations caused by industrial agriculture. Industrial agriculture, an advanced form of farming initiated by Homo sapiens around 10,000 years ago, was designed to produce food in a concentrated form primarily for safety reasons rather than scarcity. Initially, this agricultural practice relied on human labor, evolving to animal-powered tillage, and eventually transitioning to mechanical power, leading to what we now call industrial agriculture. This progression can be termed ancient conventional industrial, ACI, agriculture. However, this evolution has significantly disrupted natural ecosystems, leading to widespread environmental degradation. One. Inundation of soil with water. Industrial agriculture often involves extensive irrigation, which can inundate the soil, drowning soil life. Excessive water disrupts the delicate balance of the soil ecosystem, adversely affecting microorganisms and other beneficial organisms essential for soil health. 2. Destructive tillage practices. Tillage, particularly with heavy machinery, demolishes the habitat of soil microbes. This practice disrupts the soil structure, leading to the release of stored carbon accumulated over millions of years. Moreover, intensive tillage accelerates the evaporation of water, contributing to soil aridity and reducing the soil's ability to retain moisture. 3. Bare soil exposure. After harvest and plowing, fields are often left bare, exposing the soil to direct sunlight and radiation. Soil is not naturally meant to be left uncovered. Bare soil warms up quickly, disrupting its thermal balance and further degrading its quality. The increased warmth can push clouds higher into colder altitudes, leading to the formation of hail, which can severely damage crops. 4. Formation of hard pans. The use of heavy farm machinery compacts the soil, forming a hard pan layer beneath the surface. This compacted layer restricts water infiltration, preventing effective recharging of aquifers. Consequently, the natural process of groundwater replenishment is hindered, exacerbating water scarcity. 5. Loss of soil fertility. Continuous monocropping and the extensive use of chemical fertilizers deplete the soil of essential nutrients. Over time, this leads to a decline in soil fertility, requiring even more chemical inputs to maintain crop yields, creating a vicious cycle of dependency and degradation. 6. Increased greenhouse gas emissions. The disruption of soil structure and the release of stored carbon contribute to increased greenhouse gas emissions. Agricultural practices, including the use of synthetic fertilizers and pesticides, further amplify these emissions, contributing significantly to climate change. 7. Impact on biodiversity. Industrial agriculture often involves the conversion of diverse ecosystems into monoculture fields. This reduction in biodiversity impacts not only the variety of plant and animal species but also the resilience of ecosystems to pests and diseases. Eight. Crop damage from hailstorms. Higher levels of water vapor and the warming of bare soil increase the likelihood of hailstorms. The rising air, warmed by bare soil, can push moisture-laden clouds to colder heights, where hail forms. These hailstorms can cause significant damage to crops, further impacting food production and quality. Consequences for food production and quality. The practices associated with industrial agriculture have led to devastating consequences for food production and quality. The reliance on chemical inputs has resulted in food that is often nutritionally inferior and laden with pesticide residues. Furthermore, the environmental degradation caused by these practices has led to increased production costs, making food more expensive. Conclusion. The extraction of groundwater and the practices of industrial agriculture, while significantly increasing food production, have brought about severe environmental, geological, and ecological consequences. The inundation of soil with water, destructive tillage practices, bare soil exposure, formation of hard pans, loss of soil fertility, increased greenhouse gas emissions, impact on biodiversity, and crop damage from hailstorms collectively contribute to the current levels of devastation. These practices have resulted in the highest food costs and the poorest food quality in history. It is imperative to adopt sustainable water management and agricultural practices that balance food production with environmental preservation to ensure a healthier planet and a more secure food future. As we confront these hidden consequences, it becomes clear that proactive measures and thoughtful policies are essential to address these critical issues.